All right, each time your heart beats, your blood pressure increases, then decreases as the heart rests between beats. A certain person's blood pressure is modeled by the function 90 plus 20 sine 160 pi t. So find the amplitude, period, and frequency. So what's the amplitude? What's the period?
2 pi over 160.
160 pi, which is 2 over 160, which is 1 over 80. Period. Yep. And the frequency is the inverse. So that's 80. So should be D. Same equation. You said C. Did I say? Amplitude's 20.
Amplitude's 90.
Yep.
Yeah. Wow.
You good?
Yeah.
Each time your heart beats, same equation. Now it says if a person's exercising, his heart beats faster. How does that affect the period and frequency?
The frequency increases because it's doing it more often.
Mhm.
The period increases because it's going to the same spot.
Period decreases because it's the inverse of frequency. Right? So when frequency goes up, period goes down because they're inverses of each other. Okay? Astronomers believe that the radius of a variable star increases and decreases with the brightness of the star. The certain variable star has an average radius of 25 million miles and changes by a maximum of 1.5 million miles from this average during a single pulsation. The time between periods of maximum brightness is 5.4 days. Find an equation that describes the radius of the star as a function of time. Well, I gave you multiple choice, which saved you on this one, because all you really needed to do was look at the period. Period was 2 pi over 5.4, and there's only one, letter C, that matches that. But if I were to graph it, it starts at 25 million, right? And then it increases by 1.5. So it's going to do one of these. So the 25 million represents the vertical shift. And then the 1.5 would represent the amplitude. Okay. All right. Find the period and graph the function. So what's the period? Pi. Where are the normal asymptotes? On tangent, secant, and cosecant, it's easiest, or in cotangent too, to find the asymptotes and then figure out where the asymptotes shift when you're trying to find the graph. So where are the asymptotes normally? On tangent.
Is it in between 0 and pi over 2?
Nope.
Oh.
It's everywhere cosine is, because it's tangent sine over cosine.
Yeah.
So the asymptotes for tangent happen everywhere cosine is 0.
0 and pi over 2.
Where is cosine 0? Where is x 0 on the unit circle? Pi over 2, 3 pi over 2, and all iterations of that, right? And so tangent has asymptotes at negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, right? But it shifts right pi over 4. So now the asymptote's at negative pi over 4, 3 pi over 4. It's just every asymptote shifts over pi over 4. And does tangent go from right to left or from left to right? Right to left. So fortunately, maybe, I give you graphs. So it can't be these two, and definitely not B or C. I think I went too far. Did I? 3, 4, guess not. So I didn't even have to worry about the asymptotes. There it is. But you can see normally the asymptote's at pi over 2 and it's shifted over pi over 4. That's why it's easiest for me to just figure out where the asymptotes go. Okay, find the period and graph the function of cosecant. So cosecant is the inverse of inverse of sine. So one of the things I can do to rule out is the period has to be what for cosecant? What's the period of cosecant? 2 pi, same as sine. Okay, so A is not it, and C is not it, or D. No, C. Okay, now next I can rule out the fact they give me an amplitude. This one's got an amplitude of 5. This one's got an amplitude of 5 because it starts at 5 is the bottom of the little parabola. This one looks like the amplitude is 1. So now I've got it narrowed down to this one or this one. So the easiest way for me to figure this out is the asymptotes again, where the asymptotes normally on secant or cosecant, where sine is 0. So 0, pi, 2 pi, 3 pi, 4 pi. Okay? But this time they shifted left pi over 2. So now instead of 0, it's going to be negative pi over 2. So which one of those two are negative pi over 2? Both of them, right? Okay. So now I have to do one step further and figure out, so sine's normally like this, right? Cosecant is normally like this. And it shifts left pi over 2. So this is up, this is down, right? And on this one, up, down, this one is not right. So it's this one. All right?
It shifts left.
Mm-hmm. So won't this be now here? And this one, because this is going to be down. Okay, hold on. Okay, so we go up and down, right? And then this is going to go down and back up. So normally, it's going to look like this with an asymptote here and an asymptote here. But this asymptote now is at pi over 2, which is here, and at negative pi over 2, right? So it's actually going to be like that. So yes, B. Thank you. Okay. Assuming an angle in quadrant 1, find the exact value. Well, this is 4/5, so tangent is 3/4. Okay, this one, I had to, because I did this one too, I had to graph it so I could wrap my head around what it was saying. So actually, why don't I graph it with actual graph paper? And we'll start, January is, I'm going to make January here, February, March, April, May, June, July, September, October, November, December. In January, it goes from 21 to 77, it's my high and low. So here, I'm at 21. February is at 27. I'm just gradually going to get higher till I hit 2, 3, 4, 5, 6, 7. This one is at 77. And then it just gradually, it's not exactly the same points on every side, but you get the idea. So there's your sinusoidal function, and then it just repeats. So what do I want to use, sine or cosine? I would say cosine. Let's find the midline. Or not. And how do I do that? Subtract the 2, divide by 2, that'll tell me my amplitude, right? So 71 minus 21, or 77 minus 21 is 56. So 28 is my amplitude from midline. but I'm already up 21, so that has to be at 49 is my midline. Why? There's my midline. So do you see that the graph doesn't start on the midline? The midline for the sine graph is the x-axis. If the graph started on the midline, sine would be the best to use. But it starts below the midline, so cosine is the best to use, right? The fact that it starts below the midline, though, and not above the midline, normally cosine starts above and then comes, I'll do it this way, above and then comes back down or back up. If it starts below and goes up, it's going to be negative cosine. The problem is there was not a negative cosine answer, right? So there has to be a phase shift in your answer. So we're going to use cosine, but we want the graph to actually start right here at that point and then shift over. You know what I'm saying? So we know it's cosine. We know 28 is my amplitude. So I can narrow it down to this one or this one. So now I need to find the period. Well, it takes 12 months, right? So 2 pi over 12, pi over 6. So it has to be this one, A, right? Okay. Next. Arc cosine -7 over the square root of 130. Where is this angle? What quadrant? 2. Cosine is, arc cosine is only 1 and 2. And since it's negative, it's in 2. Okay, -7 square, oh, let's do it in 2, not 3. -7 square root of 130. And 130 minus 49, square root of that, 9. And sine then is 9 over the square root of 130, positive, because it's in the second quadrant. Okay, write an equation of the tangent function with period 3 pi, phase shift negative pi, and vertical shift 2. 3 pi, it's pi over 3 pi, right? So it'd be 1/3. Phase shift is when the coefficient of x is 1. So it can't be 1/3 x plus pi inside. That 1/3 has to be outside. If I wanted to figure out what it was, if I didn't want anything outside, it would just be 1/3 x plus 1/3 pi. So you could have answered that too. Just distribute the 1/3 in. Okay. Assuming an angle in quadrant 1, same kind of deal then. Cotangent is 12 over 5. This is, what is it? 9? Is that a special?
13.
Thank you. Cosine then is 12 over 13. Okay, what's the amplitude of the next one? 5. What's the period? 2 pi over 2, which is pi. And phase shift? Nope. Nope. Remember, phase shift is, you've got to take it out, take the 2 out. Phase shift is negative pi over 4. And the vertical shift is 1. Okay, we've talked about this one already in class. Doesn't exist. Because arc cosine or arc sine has to be a ratio, not an angle. Okay, vertical asymptotes of secant. Where are they normally? Secant. Where are the vertical asymptotes of secant normally? Where what's 0? Cosine. Where's cosine 0? Pi over 2, 3 pi over 2, so on and so on. Okay. If I shift those asymptotes over pi, they're in the same place. But what has shifted, come on. Oh. Normally, they're going to be here. Come on. You can draw. I know you can. And here. Right? And cosine starts, so secant is going to be up here. And it starts at 3 normally. Right? And it'll be down here at negative 3. But this whole graph has shifted over pi, so it's just flipped. This is now down, this is up. And that'll be your final graph then. Just change the up and down. Okay. Let's go to 15. Quadrant 1. Tangent's 12 over 5. So cosine's 5/13. This one doesn't exist. So
What if it does exist? Are there something like that? Is there one on the test like that? Okay.
no, because if it did exist, it would be arc cosine, which I could write this way. It would be a ratio, and you can tell me that angle, can't you?
Oh, yeah.
Just with a calculator, just take arc cosine of that angle. Okay, final for the bonus. The line is 3x minus y equals 0. So y equals 3x, right? Which is the slope of 3. So there's what my line looks like. But it wants it in the third quadrant. So I'm going to go ahead and draw my angle. This is 3. This is 1. And it wants sine. Sine in the third quadrant's what sign? S-I-G-N. What's the sign of sine in the third quadrant? Negative. So I know my answer is going to be negative. Negative. And I need to find the hypotenuse. It looks like the square root of 10. Square root of 10. So it'd be negative 3 over the square root of 10. And then you could rationalize negative 3 square root of 10 over 10 would be your final answer. That makes sense? Those are really easy. They just look hard. All you need to do is just draw the line and then make your reference angle and then answer the question. Okay? Questions? All right, test is tomorrow, and we'll start it on chapter 3 on Wednesday.
Is chapter 3 hard?
Chapter 3 is identities. So I'll stop.